Good morning, everyone. My name is Krista Hartsook, and I am the Iowa SARE coordinator. As part of SARE, we have a lot of different grant programs, and one of those is a graduate student grant, which our speaker was able to receive. So today we have Sharon Padilla Arias here, who is a PhD student, at Iowa State University. As she received her undergraduate degrees from the University of Costa Rica. Her interests are in integrated pest management and biocontrol. And her PhD research focuses on studying mesotunnel systems, which is a physical barrier to reduce plant exposure to the vector of, Sharon, I'm not going to say that right. Which it will help with pollination and weed control under organic production in the Midwest. So please help me welcome Sharon. Sharon, thanks for being here.
Hello, many thanks for the invitation. I supposed to be there in person, but I was coming from Costa Rica, and because of the storm, I got stuck in Miami, which I am right now. But I am very grateful with the people that made this possible, me giving this virtual presentation. So I'm very excited for it. I will apologize because I have a little bit of cough, so I apologize for interrupting in some occasions to cough. Okay, my presentation is called Managing Teff as a Living Mulch for Organic Acorn Squash and Muskmelon in Mesotunnel Systems. As I was introduced kindly, my name is Sharon Padilla Arias, and the co-authors of this research were Kefas Mande, which is a PhD student. He was in charge of the muskmelon part. Sorry, and Mark Leeson, who was the PI that helped us with this research along the years. This was possible because of a grant that Mark received from the USDA NIFA and for the grant that we received from NCR-SARE. So thanks a lot. Okay. As some people might be familiar with, some of the most important pests and diseases complexes of cucurbits in the Midwest. We have the cucumber beetles, which transmit bacterial wilt, and squash bug, which transmit the cucurbit yellow vine disease. This last disease is an emerging disease, might not be that important at the time, but we have observed a increase over the years. So that might be important. Hopefully no, but might be important in the future. More important at least. And the bacterial wilt is a, a disease is most importantly in muskmelon and cucumbers, and the cucurbit yellow vine disease is mostly seen in squash and pumpkins. The management of these diseases is through the vectors. So spraying insecticides is a management option that a lot of people uses. Rotating from cucurbits, meaning using or planting different crops which are not a host for these insects. Use perimeter trap cropping, which is basically planting a different crop around the main crop, which is going to attract the pest and spray those mainly. That strategy, I think there is different results. Some more positive, some more, some less. But it's a option. And use barrier strategies. That is another option in which I'm going to elaborate. For organic management, the insecticides that are allowed are sadly are less effective than the other insecticides. Therefore, the barriers are excuse me, barriers are one option. And as examples of barriers, we have low tunnels and mesotunnels. So this is a picture showing low tunnels, and meso means middle size. So mesotunnels are a little bit bigger than low tunnels. To expand on this, here I'm showing two more pictures, a picture of low tunnels and a picture of mesotunnels. This is Kefas installing one of our mesotunnels. So low tunnels, the cover of these tunnels are spunbond polypropylene. They are usually 18 inches high tunnels. They are wire supported. They are installed from transplant until bloom, and they do have some limitations like the short-term protection that they provide, because they can be installed when they at transplant, but they need to be removed at bloom to allow the pollination to happen. Another limitation is that they can overheat the cucurbit seedlings, especially in very hot days. The mesotunnels, by the other hand, are covered by this nylon mesh fabric. They are bigger, they are 3.5 feet high tunnels. They are also wire supported, and they can be installed during the full season. They do not overheat. That is one of the reasons they can be installed for the full season. They can be sprayed through them. We can spray through them, and they are tougher than the spunbond. This picture shows that because of the size of the mesh, they stop the pest, but they allow the wind and the liquid from the spray bomb to pass through them. However, mesotunnels also have some limitations, such as they exclude the pollinators, as I am trying to show in this picture, because of the mesh, and they also hinder the weed control because they are these physical barriers that must be um, removed in order to control the weeds. To come up with some solutions or possible solutions, we excuse me, we performed field trials during 2020, 2021, and 2022. We performed some trials to come up with a pollination strategy and some others to come up with a weed control strategy. We did this for two different crops, the muskmelon variety Athena and acorn squash variety Table Ace. So I'm not going to expand on the pollination trials, but I want to share with you and mention what we have done. During those 3 years, we installed these 3-row mesotunnels of 150 long. Those were 150 feet long mesotunnels. They were this big in order to try to make a commercial size field, so we could have a better sense of what could happen with the pollination. We compared 3 different treatments. One was a full season mesotunnel, in which we installed a bumblebee hive in the middle of the mesotunnel in the second row. We had an on-off-on treatment, in which we installed the mesotunnels at transplanting. We waited until bloom. We removed the nets for 2 weeks to allow the pollination to happen, and then we reinstalled the nets. And then we also had open ends, in which we only opened the ends for those same 2 weeks, and then we reseal it. I'm not going to expand on this. I'm just I want to mention that we had different results depending on the crops. And if at the end anyone is interested, I could explain a little bit of this and expand. But I want to share with you what is the theme of the talk for today, which is weed control trials. So for the weed control trials, we also performed it for the 3 years that I mentioned. We also had 3 rows, but in this case, 30 feet long mesotunnels, which you can observe in here. And the we tested living mulch to control weeds. Also, also we did this for muskmelon variety Athena and acorn squash variety table A's. To control weeds in organic production, we don't have that many options. So that's why we decided to use a living mulch or test it. Some of the advantages of using a living mulch is that they can protect the soil against erosion. For instance, in this picture, you can observe how the soil can get eroded after a rain event. The living mulches also build organic matter, because all of these plant material and the roots that we cannot observe in this picture, for instance, gets into the soil and helps to build this organic matter. And they also suppress weeds and weed seeds. I will expand on this with our results. So for 2020, we tested 4 different treatments in the soil furrows between the plastic rows. We had a weed fabric treatment in which we installed the weed fabric in here. Then we tested teff, a non-coated teff at 2 different densities, because we didn't know which density was the best for our system. So we tested teff at 4 pounds per acre and teff at 8 pounds per acre, both non-coated, and bare ground treatment. The teff, we planted it with a Gandhi cedar. Here you can see a picture of Kefas just like planting it just before starting the transplantation, the very same day. For the markable yield of muskmelon, in here, in the x-axis, you can observe the different treatments, and in the y-axis, you can observe the pounds per acre of muskmelon. You can observe in here that the teff reduced the yield in comparison to the wheat fabric. If we move to the acorn squash results, I am also showing here the pounds per acre of acorn squash and the different treatments. And in here, you can observe that teff at 4 pounds per acre reduced the least the yield, was similar to using the wheat fabric, and was less, reduced the yield less than the 8 pounds per acre. So that part of the changes that we made for 2021 and 2022 is that we planted the teff, or we decided to plant the teff at 4 pounds per acre. And we decided to mow the alleys in this treatment at 4 inches height at bloom. In this picture, I want to point out that this is teff, and you can observe only few different weeds around there, because the teff is, when established properly, it competes very well against the weeds. This one is a picture of one of the early workers mowing the weeds. You can observe how many weeds we had in the alleys. And in this picture, this is how the teff looks like just after or very close to harvest. All this organic matter gets incorporated into the soil, and the root system that they produce, it's very big. I am going to show you a picture. So all that goes into the soil. Teff do not overwinter, do not survive Iowa's winter, so that is a very good option to control weeds. So in 2021 and 2022, we tested 5 different treatments. One still was the weed fabric installed in between the alleys. We had a non-mowed teff planted at 4 pounds per acre, a mowed teff planted at also 4 pounds per acre, a mowed bare ground, and a non-mowed bare ground. Here I'm showing the markable yield of the muskmelon for 2021 and 2022. In the y-axis, you can see the pounds per acre, and in the x-axis, you can see the different treatments. For muskmelon, in both years, we observed that the mowed teff had a similar yield in comparison to the wheat fabric, which is very promising. So mowing teff at bloom eliminates yield drag. Also here, I'm showing you the wheat growth in between the alleys for the muskmelon trials. And in here, you also can observe that the mowed teff reduced the wheat significantly. Here I'm showing the grams of wheat, dry wheat weight inside a 6 square feet quadrat. So mowing teff at bloom reduced the weeds. However, in 2021, acorn squash blooms at a different time in comparison to the muskmelon. So usually, muskmelon takes around 21 days to bloom. Acorn squash takes around 35 days to bloom. So in 2021, because we decided to mow at bloom, because it's when we were moving the mesotunnels, the nets, we decided to mow at 35 days after transplanting, this for the acorn squash. But you can observe that the markable yield was significantly lower than the wheat fabric. So in 2022, we decided to mow earlier the teff in between the acorn squash and also the bare ground for the mowed treatments. So in here, you can observe what happens when we mow 21 days after transplanting. So mowing teff and bare ground 21 days after transplanting reduced the yield drag in acorn squash. For the width growth for the acorn squash, when we mowed 35 days after transplanting, we observed a reduction of the weeds in comparison to the other treatments. But when we use teff and mow it 21 days after transplanting, that reduction was very similar to the wheat fabric. So mowing teff 21 days after transplanting reduced weeds. We also performed an economic analysis. So we made a partial budget to compare between treatments. We used the cost of materials and labor that were different between treatments, and the yield resulted from the different treatments. As I showed you before, the same yield. So we made this, use this formula, which is the cost efficiency. It basically is taking the yield of a given treatment, let's call it treatment A, between the cost of that treatment. And we divided that between the yield and the cost of a second treatment. That gives us the cost efficiency. So for instance, if the cost efficiency exceeds 1, that means that the treatment A is more cost efficient than the treatment B. So this is a comparison between one treatment and the other treatment, what it gives in yield in comparison to the cost. So the economic analysis for the muskmelon, here in the y-axis you can see the relative cost efficiency rating. This baseline is at 1, and in the different in the x-axis you can see the comparison between the different treatments. So for instance, NMB means non-mowed bare ground, MB means mowed bare ground, LF means landscape fabric, NMT non-mowed teff, and MT mowed teff. So here we are showing different comparisons and we have 3 different graphs in each comparison. The one that has bricks, that one is for 2021. The one that is pointed, that is for 2022, and the one that has lines, that is for the 2-year average. And remember, the baseline is at 1. So for the muskmelon, basically, the landscape fabric and the mowed teff give a very similar result, meaning those 2 treatments are compared in the economic analysis. So the cost efficiency of mowing teff was similar to use with fabric, and those were the treatments with the higher yield. If we jump to the acorn squash, here I'm showing the same graph, the relative cost efficiency baseline, and the two years and the 2-year average, and the same treatments. For the acorn squash, I want to point out that these 2, 2021 and 2022, the mowing was done at different times. So I want to comment on the 2022. That is what is very similar between the mowed teff and mowed bare ground in comparison to the landscape fabric. So the cost efficiency of mowing teff and bare ground 21 days after transplanting was similar to using with fabric. So in terms of how much is invested and how much is returned, those 2 are similar. However, the labor requirements are different, and I think for this presentation that is important, so farmers can make decisions based on what they have available. So in here I'm showing the labor time in hours that we spent in our 30-feet mesotunnels, that in the y-axis, and in the x-axis we have the different weeks that we had our experiments on place. The yellow line in here is with fabric, the red one is mowed teff, and the green one is mowed bare ground. So I want to point out that with fabric had 2 peaks on labor. One is the installation, which was higher than the other treatments. Mowed bare ground didn't have any installation. It's basically having or widths, the widths that were in place, which might be different in comparison to other places, but well, that is not the point. Mowing teff, for the mowed teff treatments, we had to plant the teff, as I mentioned before, so that had some labor involved, but not as much as installing the wood fabric. Then we had some labor here to mow the mold treatment, but here to remove the landscape fabric, I think that is the most significant peaks on labor because we couldn't let those on place during during the winter. We had to remove it. So the labor for mowing teff or bare ground was much less than the wheat fabric. So as a summary, mowing teff 3 weeks after planting eliminated the yield drag in muskmelon and reduced it in acorn squash, meaning that using teff and managing this teff might be a good option to control weeds under this system, and even not necessarily with the mesotunnels, but by themselves to control weeds. The most cost-efficient treatments were the landscape fabric, followed by mowed teff in muskmelon, and mowed teff and mowed bare ground in acorn squash. And living mulches reduce erosion, builds soil organic matter, and have no disposal problems, unlike the wheat fabric. So some of the considerations that might be important to well, some of the things that might be important to consider are these other services that using a living mulch represents, and uh, the amount of labor, and so many other factors that you might want to consider. This is the picture of the teff roots under the plastic mulch. In 2020, I think Kefas moved the plastic, and he observed all these roots from the teff going um, under the plastic mulch. So all these roots, first, they can compete against the crop because they are very massive, but that is one of the reasons why I think by mowing it, you are also controlling the whole plant, meaning also the roots, and that might be one of the reasons why they are not that aggressive when mowed. I also want to mention on this picture these naked soil line like alleys that you observing here are the ones in which we removed the landscape fabric. So I want to point out that in that treatment, that soil was going to be naked for the whole winter, in comparison or in contrast with using the other treatments, which were teff and the mowed bare ground. That those treatments are going to be were protecting the soil further. Some take-home messages. Teff has a living mulch for organic cucurbit production. Teff has also been used for pumpkins. That is, we found this information from Rhode Island University, and we use this um, to come up with this possible for this research. So if you want to continue reading about teff and some of the considerations that you want to consider, that that work might be of your interest. Mesotunnel showed profit potential for organic muskmelon production in the upper Midwest, but less so for the acorn squash. I know that I'm not showing this information in here, but I invite you to read some of the publications that we have thus far, because that might be something to consider. Basically, the muskmelon, the pressure of the cucumber beetles and the disease that they carry is very high in Iowa, and it's not that high for the acorn squash, for the squash bugs and the uh, cucurbit yellow vine disease. This might change, this might not change, but it's part of the research that we have done. Mesotunnel's results can vary with geographic region. That is something that we observe because part of this research was done or this research was done in Iowa. That is the results that I am presenting. But we have some colleagues that made the same experiments or similar experiments in New York and in Kentucky. So you might see differences with the mesotunnels, with the pollination, with control, everything. So that is something that you might be interested on checking. For future research, we think that, or we have here from farmers that extend mesotunnels to other crops might be something interesting. I remember one farmer using or trying to use mesotunnels for a broccoli. So if someone incorporates mesotunnels under their toolbox, uh, using it in different crops might be something interesting. And grow multiple mesotunnel crops in the same year, um, that might be something interesting too. I invite you to check on the tips for using mesotunnels. This is a grower's manual that was put in place from our group. This is the link to get to the grower manual. I'm sure that you're going to have access to this presentation, and you also can Google current curbit, and you will find that information. Some teff recommendations: seed and water at crop transplant. Watering is especially important if the days are too hot, if the soil is too dry. You might want to water a little bit. We have water with the mesotunnels in place. We have water just above with a hose. So that is something that you can try if you have it, have these tools. Something that I haven't mentioned that I think is very important too is we tried to plant teff ahead, like 1 week ahead, the transplanting the main crop, and that didn't work that well because the teff was coming small plants, and with the tractor they got damaged and they didn't come up. So after we came up with this option in which the soil was prepared, the plastic alleys, no, not the alleys, the plastic rows were put in place. At that point, the same day of transplanting, we planted the teff, and then we just after that, the tractor came and transplanted the main crop, and then we closed the mesotunnels. If it didn't rain in the coming days and the soil was too dry, then we water. So something to mention, we have tested different options, and that was the best one. We also recommend mowing to 2 to 4 inches 21 days after transplanting for both of the crops, the muskmelon and the acorn squash. And we recommend using a flail mower on a busy track. Some acknowledgements that I want to give: Dr. Wendon and Dr. Nian Chen. They were the researchers in charge of the economic analysis. This economic analysis gave us a better idea on what to recommend. So we want to acknowledge their contribution. And to Jose Gonzalez, which was the um, lab manager at the time. He made it possible. A lot of the research, he was a very important person to make this possible, and he also helped all the group to coordinate, like Iowa's group with the Kentucky and New York group, which was a very rich research. Here, a picture of some of the early workers that help us um, from 2019, in which we made some mesotunnels research to 2022. here you can see teff. And we want to thank our funding sources, which were USDA, NIFA, and North Central SARE. And thank you for inviting me to give this presentation. I will be happy to answer any questions right now, or you can reach to my Iowa State email. I will be very happy to answer any questions. Thank you.
Thank you, Sharon. Appreciate that information. It's always fascinating to me to be able to see how well the teff did in growing. And I know I especially enjoy visiting when I'm out at the farm. So couple of quick questions. One was, if were you planning to continue this same type of research or transition to something else, or is your project, your portion of the project complete?
My portion of the project is complete. Right now, I'm working, or I will continue working for my PhD in biocontrol of Erwinia trachyphylla, which is the causal agent of bacterial wilt in muskmelon. But if someone is interested on the teff research, I am aware that some people will continue doing research on this area. So Ajay Nair, I think he will continue researching on this. And I am aware that the Iowa State Horticulture Farm, they incorporated the teff in many different areas of their, like to manage weeds. I remember that they were using it in areas that were not being used for crops. So there, I think teff at least is being used and will be continue. People will continue doing research on it.
Yeah, thank you.
Thank you.
One other question was, did anything really surprise you in your research?
Thank you for that question. Yeah, the picture that I showed of the root system for the teff, I didn't expect it. Even like it didn't occur to me to check on the roots. And Kefas was the one that, out of curiosity, he moved the plastic, and we observed that a massive root system. So that is something that surprised me. And but after talking and after thinking about it, was like, okay, this teff comes from an African country, I think was Ethiopia, and is very resistant to drought, like dry conditions, right? So it makes sense that it makes these massive roots to survive these conditions. So yeah, that is one of the things that surprised me a lot. And well, something else is I am an agronomist, so I am used to some to the um, work in the field, but it surprised to me also how much effort we need to put in order to grow things, and the pressure that is. So that is something else I want to point out, that I admire all that effort that people put in their crops.
Thank you, Sharon. I really appreciate that and appreciate the questions that we had. And I really appreciate your flexibility and willingness to present this remotely. So safe travels back. Maybe soak up some sun in Miami before you head back to Iowa, because it's very snowy here.
Okay, thank you. I will.
All right. Thank you so much. Appreciate it.
Thank you. Thank you for all the help.